In this section, we'll be studying rates of change. And the other thing that we'll be looking at is the behavior of graphs. So after we go over rates of change, the main idea in this section is that we want to study the structure of a graph by its equation. So this idea is a little bit outside the scope of this class, so instead we're going to do the next best thing. We're going to study the behavior of a graph given the graph itself. We'll go ahead and introduce the main ideas of this section. In part A, we'll be looking at rate of change. In part B, we'll introduce a lot of different ideas, like an increasing function, decreasing function, what local maxima and local minima are, and what absolute max and absolute minimum values are. And in all of this, what we're going to do is we're going to use this language to determine the behavior of graphs. So let's introduce some of these ideas using the previous motivation from section 3.2. Recall that we can model the height of a projectile with the following function. The graph of this function is the following. It starts at time is equal to 0 on the ground, and at time is equal to 6, it hits the ground again. The graph of this function reaches a maximum point, and then at some point it begins heading back to the ground. So the first thing that we can take note of is that the flight of the projectile takes 6 seconds. Before our projectile reaches maximum height, the height of the projectile is growing in size. After the projectile reaches a maximum height, our projectile starts losing height. This max height here is an example of absolute max value. And these intervals that we've drawn down here, the green interval and the blue interval, describe what's going on with both the projectile and the graph itself. So all these things I just highlighted are what we're going to be going over in part B. Behavior of the graph. Now, in part A, what we're going to be looking at is we're going to be looking at the average change in whatever time unit or whatever unit we're looking at. In the case of this projectile, we're looking at, if we wanted to find the average rate of change of this projectile, it would be described as the average change in height over a period of time. Oops, this should be average rate of height over time. In this example, another way of saying the average rate of height over time would be the upward velocity and the downward velocity.